Well, hello, this is Mrs. Becky again, and I'm here this time to explain pre-calculus IXL section F9, and that's matching polynomials, which are these guys, to their graphs, which are these guys, using the zeros, which might be something that you're not familiar with. But the zeros are where the graph intersects the x-axis. So these, again, these polynomials, these equations, they make shapes on the graph. And the zeros tell us where these graphs are actually hitting the x-axis. And there can be more than one of them. What we usually do first is we would use the factored form of these polynomials, which is probably something from Algebra 2, Algebra 1, Algebra 2 that you totally blocked out on how to factor these equations. But lucky for you, IXL has done that for you. So we can take an equation, which is pretty much just addition and sometimes subtraction, a whole bunch of things being added and subtracted together, and we can put them into a factored form, which means we're multiplying them. So this f function, the f of x factored is then x plus 7 times x plus 6. And that's a whole lot of fun for another day, but they've already factored it for you. Oops. Well, so the first thing that you'd want to do is you would, from the factors of each equation, so f of x, we'll start with that one. Oops. So the f of x equation in its factored form is x plus 7 times x plus 6. So if you FOILed this thing out, this times this x times x, x times 6, 7 times x, 7 times 6, then it would give you this original equation right there. So from factored form, what we know is that when you have two things that are being multiplied together, like say you have this number times this number, and we don't know what they are. If it equals 0, what we know about getting a 0 answer is that one of these guys has to be 0. Like if this was 4 times something, to get it to be 0, this would have to be 0. Oops. If this was 7, we knew that that was 7. To get it to multiply it by something that would get it to be 0, this would have to be 0. Oops. Anyway, so that we're going to use that idea to then be able to figure out where the zeros are. Okay, so what we're going to do is we're going to take this one, x plus 7, and we're going to make it equal 0. Okay, so what if this one was 0? Again, we're looking for what zeros out the y, which is represented as this now. Is this the same thing as y equals? So what would zero that out? So again, we take these factors, we set them for 0. So we want to solve it for x, get x all by itself. Well, this one is pretty simple. So if we subtract 7 from both sides, we get x equals -7. Ooh, that's a -7. Then if we take this factor over there, x plus 6, you can have a bunch of these factors also. Here we only have 2. Set it to equal 0 and solve it. We want x all by itself. Subtract 6 from both sides. So x equals -6. These are its zeros. This f function hits the graph at -7 and at -6. And if you look closely, this graph hits at -6 and -7. So that would tell us that this is the f function right here. Okay. All right, hold on 1 second. Oh, how am I going to pause it? Pause. All right, we're on to the next example. If you notice, these are quartics, so they're raised to the fourth power. And notice that wobbly shape there. This one can be deceptive because um, it looks like it's a quadratic to the second power, but it's not. There's some clues here to notice. Again, this graph hits the y-intercept at +3. That's a pretty good clue that it matches this one. This one hits the y-intercept. It has to go way up to +225 before it ever hits this y-axis. But we are focusing in on the zeros. And again, we get those. IXL was nice enough to factor this, take it out of this form and factor it for us. So what we have to do, though, is set those to equal 0. Let's see, which one do I want to do? I'll do this one first. I want to show you something. If you notice, this has an x squared on the inside of one of those factors. I'm going to set it to 0. Now, we want to solve for x. These parentheses are really not helping us with anything here, so we can drop. Wait a minute. Hang on 1 second, guys. My battery saver's on. That's going to be really bad. That was so close. My battery almost died. So again, we can drop these parentheses and solve this equation for 0. We want to get this x squared by itself, so we would subtract the 1 from both sides. So on this side of the equation, it's a -1. I'm just going to use some shortcuts there. We want to, I don't know if you remember, to undo this squared, where x is squared, opposite or the inverse of that is the square root. So if you take the square root of x squared, that gives you x. But what you do on one side, you have to do the other. So we have to take the square root of this -1, which it doesn't really have an answer. And if you remember, square roots have two answers. They have a positive answer and also a negative answer. Now this is not a real number, as you can see. And if you remember, we call the square root of -1, it's an imaginary number represented by I. So what that tells us is that's an imaginary number. It's not going to hit this x-axis. So you can see this one is floating up here, and it's not going to hit the x-axis. We could go ahead and factor out this one in the same manner, but it's also going to it's not going to help us any. So take note that if it's in this form like this, it's not going to factor into a real number. So you know that it's not going to hit the x-axis that way. And also we noticed with this equation, the f equation, that it hits at +3 there. So you can see it has no zeros, not hitting the x-axis, and it hits at +3. Let's get rid of that. And now the other one, did I do this one? What did it do there? All right, we'll do this one. So if we take x plus 5 squared, set it to equal 0. Do you remember how to get rid of this guy? You are so smart. To get rid of it, you take the square root. What you do on one side, you have to do the other side. What that then just gives us is you pretty much this thing cancels this thing. So what we have left is x plus 5. And the square root of 0, 0. Then you solve that. We want x by itself. we're going to move this 5 over here. So you subtract the 5, it's a negative 5 on that side. So one of these roots is going to be a negative 5, but this equation has another one. Now, if you want to just take the shortcut rather than doing all that, notice when it's in this form and it looks like this, the answer is going to be the opposite of what that is. So this was an x plus 5. The 0 ended up being a negative 5. This one then would end up just being negative 3. So it saves us a whole bunch of time. So it hits the x-axis at negative 5 and also at negative 3. Here it is at negative 3. Here it is at negative 5. This isn't doing us any good unless you got on Desmos or something and looked at the graph and took it way out. Then you could see where it crosses. So that tells us that this graph is g of x. This, right? Did I do that right? Yep. Right. And this one was f of x. Okay. That was a little belabored, but okay. Don't be scared. This one should be quick. Okay, this is example 3. Now, if you notice, this coefficient here is negative, so it's going to open down, but so is this one. This one is also opening down. They are both quartic functions to the 4th power, although they're appearing to be squared parabolas. This one factored, if you remember, didn't I tell you? Yeah, that one, if it looks like this, where that x squared is inside of the parentheses in this manner, like both of these are. Remember, I did all that stuff and we ended up with something where x is like the square root of like negative 3 or something like that. They end up just not being real numbers. So the shortcut is just to realize that this is very suspect, that it's not going to hit the x-axis. You could do all that work and solve that, and I mean, it's going to end up being some imaginary number or something like that, which I don't have it written down, so I don't know. But this gives us another clue. It's going to hit the y-axis, this is the y-intercept, at negative 2, which this one does. So it has both of the clues. It's not hitting the x-axis, it's hitting at negative 2. So we can comfortably say that this one is f of x function. And then we look at this one. It's hitting at negative 2, which it does right there. It's opening down. And when the exponent is on the outside of the parentheses like this, what ends up happening when you go and you solve it, that's when the 0 is going to be, just change the sign of this number right there. The sign of that right there from negative to positive, and it's going to be a 1. So the root should hit at a positive 1, which it does. So this is g of x. And again, I'm belaboring these points a little bit. You'll probably zoom right through it. Oops. Pause. Hey, I said pause. So this is the last one that we're going to do, and I'm not going to do all the mathy math. We're just going to look at the clues that we've been going over. And if you want to, you can pause the video and see if you can do it on your own. Okay, well, if we notice, they are all quartic to the 4th power. They have their different shapes. If you remember what I told you, that if the x is squared in this form, not like this one where the square is on the outside of the parenthesis, it's on the inside, then it's not going to have any roots and it's not going to hit the graph at all. So we can just tell that off the bat. And if you remember, if you look at the constant, which is 2, that tells us that this graph hits at the y-axis at 2. So the f graph is this one. See, it hits at 2 and it has no zeros. So this one here is f of x. All right, now this one is a little sketchy. It didn't have just a plain old number, but again, you can add a 0. So we know that it's hitting the y-axis at 0. But then notice these two factors right here. Again, you can just take the opposite. This is +2, +3. But this one here is just a plain old x. But if you were to go and set it to 0, I mean, it's already solved. So if there's just a plain old x as one of the factors, that means that it hits x at 0. That is our g function. So putting all our pieces together, you see it hits the y-axis at 0. It's hitting the x-axis at 0. It's also hitting at +2 and +3. So this guy is the g of x graph. Moving on to the next one, this y-intercept is way too big on both of these. This power's on the outside of the parentheses, so just take the opposite sign. So the 0 is going to be at a +4, and these are all positive graphs. They're all opening up. So all we need to do is find the graph that hits at +4, which is this one. It only has one x-intercept. This one is going to be h of x. My h's are always looking like n's on here, which leaves this one to be k of x. And again, its y-intercept is way too big, but it's we can take these factors, change the sign. That's going to be -6. It's going to be -4 and -3, -6, -4, -3. And that's how that goes. And I think that's all I have to say about that.